Welcome to the wonderful world of equations. We're going to start with one-step addition and subtraction equations. Now, before we can go into this, I need to cover some vocabulary because I'm going to be using some words over and over and over, and you have to know what they mean in order to follow along with my directions. The first one is a variable. A variable is a letter that represents a number. That represents a number. This is what you're solving for in an equation. So it's going to be your x, your y, your z, whatever it is. But it's what you're solving for. A constant is a number with no variable part. Variable part. So in other words, it's a number by itself. Okay? The terms are parts of an expression, which is like an equation just without the equal sign, or an equation that are added together. Now that also includes subtraction. Remember, subtraction you could change to addition, but by definition it's written as added together, but addition, subtraction. And then coefficient is the number in front of the variable. So if I put down something like this, 3x plus 5. 5 would be constant. The terms are going to be 3x and 5. The variable is just x, and the coefficient is 3. Something that's important to note, if I had this, and I asked you what was the coefficient, there still is a coefficient. If it's not listed, or there isn't one written here, it's the same thing as having 1. 1 times x is still x. That's why we don't write it, okay? But it is the same thing. All right, let's move on and try and solve an equation. I have a very simple example here, and I like to start simple because I want you to be able to see the solution before we even start, so that way you believe in the method. So looking at this one, you should say, oh, I already know what the answer to this one is. It's 8. Yay, good for you. But this is what you need to remember when solving equations. First, our goal is always to isolate the variable. And you're like, oh, well, that's nice. What does isolate mean? All right, that means to get it by itself, okay? So I'll put it in parentheses. Get it by itself. All right. How do you do that? That is a good question. What you want to do, you do this by using opposite operations. So you got to remember what opposites are. The opposite of addition is subtraction. The opposite of multiplication is division. The opposite of an exponent of their power is a root. We won't cover that just yet, but we'll get to that soon enough. You solve all of these, though, by doing opposites. One thing that's really important for you to remember, whatever you do on one side, I wrote 1 right there, see? On one side of the equation, you must do it on the other side as well. That is extremely important. It's really cool because when it comes to an equation, you can do whatever you want to it mathematically, and you're not going to change it so long as you do it to both sides. You'll change the way it looks, but you're not actually changing the quantity here, the proportion. So it's really important for you to understand. So I always think of the equal sign as if it's the fulcrum of a teeter-totter, okay? Here's your teeter-totter, there's your fulcrum, right? And everything is balanced right now. If you do something to one side, whoop, it throws the balance off until you do it to both sides and it remains balanced. So that's what you can think of. The equation is like a teeter-totter. It's perfectly in balance with that equal sign being your fulcrum. All right, let's solve this. Ooh, I should mention one other thing, because this is something that I require of you, So I'll put a little star here. Because I am extremely particular about the way I want my equations to look when you solve. What I want you to do is write, or I should say solve equations going downward. One thing that you could think of when I say this is I don't want to have two equal signs in the same row. That looks bad. You're going to solve an equation going downward. So let's use this now to solve this equation. We already know the answer is 8. Well, great. How do we get that? Remember, we want to isolate the variable. You do that by doing opposite operations. So right now I have a plus 5 here that I want to get rid of in order to have the variable x by itself. The opposite of a plus 5 is a minus 5. Remember, our rules said, though, whatever you do to one side, you have to do to both sides. So I'll do that here, too. On the left, I have 5 minus 5. That becomes 0. So in other words, it's gone, leaving only my x. Then I have is equal to 13 minus 5, which is 8. There's my solution. Beautiful. That's what we said it should be. Now, another thing that you could do with equations, which is a wonderful thing, and I'm going to require it of you, is to perform a check step. A check step, you're actually going to write the word check, and then what you're going to do is you're going to take whatever you say the solution to the equation is, I'm saying x is 8, and you're going to substitute it into the original equation for the variable. So, if I say x is 8, then up here I would say 8 plus 5 should be equal to 13. If I do 8 plus 5, I get 13 is equal to 13. If I end up with a true statement, which I do, that means I found the correct solution. This is a fantastic thing because it means you could turn in a test and essentially know that all of your problems are correct and know what your grade is the minute you hand that test in, provided you actually do the check step. A lot of students will put the numbers in there and then they'll just make the math work. They don't actually calculate it. They'll just see, oh, the right's 13, the left has to be 13, so they'll write 13 equals 13. And they didn't actually check it. If this statement is not true, that means that your answer was not correct. You need to go back and fix it, because they're not all going to be this easy. Okay? Let's move on. Some more easy ones, though, for today. I have 4 samples here that I want you to try to solve. Remember, work your way downward, do opposite operations, isolate the variable, always the goal. Try and solve these, perform a check step. Pause the video now. Okay, for this first one, the opposite of a negative 7 is a plus 7. I do that to both sides. And I have y on the left and on the right 45 plus 7, which is 52. So I'm saying y is 52. Well, let's check it to make sure. 52 minus 7 should be equal to 45. Hey, 45 equals 45. It works. I'm right. Yay. Next one. I have a 3 plus f. Whoa, what's going on here? Well, they're not all going to be written in order, my friends. If I have a positive 3, how would you get rid of it? By subtracting 3. Do the opposite. On both sides. I have 3 minus 3 gives me 0, leaving me with just f. 30 minus 3 is 27. Perform a check step. And I have 3 plus 27, because that's what I'm saying f is, should be equal to 30. And sure enough, it is. I'm right again. This is a good day. This one over here, well, that's kind of ugly looking. What you could do before you actually solve this is you can get rid of this double negative. Remember that minus a negative is the same thing as plus a positive. So if you just wrote it like this, it'll make it much easier for you to solve. Now what I'll do is I'll get rid of this minus 9, or that positive 9, sorry, by subtracting 9 on both sides. And then I have z is equal to 0 minus 9, which is negative 9. I'll perform a check step. And I have negative 9 minus negative 9 should be equal to 0. This is negative 9 plus 9 equal to 0, and 0 equals 0. Sure enough, it works. Then my last problem here, I have a negative 12. I'm going to get rid of that by adding 12 to both sides. Negative 12 plus 12 is 0, and I have c is equal to 36. I check. I have negative 12 plus 36 should be equal to 24. And sure enough, it is. Isn't that beautiful? Welcome to Equations. We're on a long road of fun, my friends. Goodbye.